here we go. Going back to the simulator. I made some changes here. Alright, so we're going to actually decrease the emit rate, photon speed. The spread, we're going to leave the way it is. So we're going to unpause it. Now we know, let's go here. Now we know where the stream is. Now when we zoom in, what happens is, the zoom function is actually capturing a real property. As you're moving in towards stream, moving towards light, you'll notice more light is coming. Now from the direction that you're coming from, light is still traveling. You can't stop it. So it will give you this effect, right? It's actually, now at any angle that we take, right? At any angle you take, light will follow. If it's part of this coverage, right? Light will follow. So if I try to go in a circle, because I'm literally moving the camera, but because light is visible in all angles, watch what happens. Creates a perfect circle. Okay, and then the more it does, the more intensity, right? So because we're traveling at the speed, so wow, we created a ring. If we go up and down, we go the opposite, right? If we unpause it, that goes away, right? Because that was just visually a camera, right? So basically, upon observation, there's a collapse, and then there's light. If you were to be able to pause it and look at all the angles, you'll see the beautiful patterns that happen at the quantum. It's almost like at the quantum level, right? The probability. So let's do it again. We paused it, and we're going to just move our angle perspective. Now there's still light there because light cannot be, even in the darkest places, darkest, there's light. But what happens is when we move into perspective, there is a pattern that emerges. Right? Check this out. We just need the slightest amount, the slightest amount of light to stop it. If you were gone, you stop it, and then you can create patterns. Right? You can do all kinds of stuff with the light because light travels. In computation, it travels. Now, when observe, watch how this, when I unpause the program, it collapses upon its stream in a direction. Now we have here a deflection property on the backside, but it's, like I showed before, it's what happens in the accumulation on the backside. Okay, so let's actually pause this. So now we're gonna, what happens is, yeah, if I do any type of zoom, moving, it will change it. But this is actually something that would happen. Anything that's outside of time and can look at light this way, it will see light like this. Now, I'm gonna just keep creating this visual effect, and I'm going to increase my camera speed so I can move in faster than the light that has traveled. Okay, watch this. So I'm just zooming in, right? You see those on the right side here, how it's just going up and down? That is the scattering that's happening, right? So there is a refresh rate that happens. And I'm gonna zoom in now. Watch this. You see that dark coming with light, right? It's like almost like dark. It's almost like a dark matter. Does the same thing as light particles. Now I don't have a function that would cancel all the particles, but if you notice, I can do the same thing with the darkness, right? It is almost like a built-in, let's delete these particles. But what's actually happening is we're moving in faster. So light either goes over, escapes it, let's increase it faster. You see how slowly, like this is darkness inside, right? Let's actually zoom out really, really fast. Right? Yes. Hold on, kids. You see how it's almost eating light itself. But it's not. It's really not. It's creating a new pattern. You see how some of those clusters got spun out? Right? So let's create, what I have to add is a function that when I unpause it, it keeps the state and save this information. But let's go ahead and go back. Reset. Now, don't think it reset our camera speed, so it reset. Increase the speed, and then we have to try to locate it. And now what we're doing is, because we kind of lost it, you know, we're out there in space. Now keep in mind, there's a limit of how many photons we can do. I have a 128 core processor. I'm thinking that I can probably run the simulation. If I can get into like the hundreds of thousands of photons, we might be able to observe even bigger patterns. Right now, what I'm doing is I'm moving in and out to see if I can see any light. Oh, there you go. Because we were too far. And so, let me pause this for a second. Yeah, pause it. I can't move it. I have to either keep that as a feature, as actually a pretty cool parallel feature, but it kind of gets in the way of me doing this. Okay, I can do that. We can see the curve, right? But also the spaces in between. That's the same thing as wavelength, right? So Tesla said that we should think in terms of frequency. Light is frequency. Everything is a frequency. You see how they're coming into these clusters and then combining together, which is not a property. They can accumulate, but they must escape eventually. Light, right? Not with the black hole that we just saw. We literally created a black hole just with this visual representation, because at the lowest level, even the smallest things like light, which is it creates these patterns. Now, intelligence, yeah, most likely, but I'm gonna keep exploring and try to keep it grounded in reality. There's things that we can't really do to light, but we can speculate that if we added certain properties, we were at certain variables that we can control, we could see different patterns. Like I said, we noticed that one, the pause, and then the all direction, from all from all direction. How do we use this information? You know, is there any utility to this information? I also have to add mouse support. I have to use the keyboard. So okay, that was pretty cool.